as a person, that kind of stuff. Then there's the idea of composition versus aggregation. And they're both the same thing, except different. Composition is when you use classes as pieces of another class. So I create a book class, and then my library has references like an array list of books. Or here's where we're going here. What is the composition of the human body? It's got a brain and a heart and a stomach, and then if we look, muscles are composed of cells, and cells are composed of nucleuses and also mitochondria, which are composed of, right, and they go all the way down here. And if we look here, some things belong actually to more categories than just one, right? Mitochondria, every single cell is has a mitochondria. Well, I think. And, you know, cells make up all of this stuff. So the idea behind aggregation and composition is that the composition dictates what it has, but there's another form of composition called aggregation, which is where one thing can be owned by more than one entity. Their example of this. You have a car dealership, and it can have a lot of cars. That's what this nomenclature shows. Is it's got a one-to-many relationship. Dealership may have 100 cars or 1,000, and so it's a one-to-many. The car can only be in one dealership. The dealership can own a whole bunch of cars. Then there's the aggregation. This manager may work for more than one dealership. I'm not sure why it's a one-to-one relationship there. But this salesperson may work for more than one dealership. He part-times at another one. The manager part-times at another one. So a solid line represents an association, either composition or aggregation. The solid diamond, the filled-in diamond, indicates composition, a singular relationship. Cars are only part of one dealership. And the hollow one represents aggregation. Salespeople, you can have salespeople who work for more than one dealership. In our case, you might have something where you have two array lists that have the same objects in it, because you could easily stick the same object in both a stack and a queue, right? And then that object belongs to two different things. So if that array list was stuck inside a class, and then you had another array list with a stack, and you were sticking the object in both of them, that's an aggregation relationship. There's nothing wrong with that, but you can get to multiplicity problems. Well, no, that's not right. You can get to problems when you're sharing the same object among more than one item. And we kind of talked about that, right? We were sticking things on an array list, but we were reusing the same reference. So if you changed an element of that object, it looked like it changed it for all the elements in the object. No, it's just same one object. It's just that you put several copies of it. Just like you have a piece of paper and you wrote down your address 7 times, and then you go and paint your house red. Well, there's 7 red houses in the list. It's all the same house, right? Or you have to pass out 2 different lists, and you paint your house red. Well, both lists have a reference to a red house. So you do have to kind of be careful if you're sharing something between 2 entities. You need to make sure that's really what you want to do. You might want to put a copy of the object in the other one, right? So that changes in one place don't affect the change in the other. On the other hand, maybe you do want them to be the same object. Maybe you do want changes in one place to be, you know. So you might have several, say you have a class, a classroom, a course. And then you can have a list of students. It's part of that course. So it's an array list, or array, of students. And then you also have an adopted textbook for that course. So an array of textbooks. And then you have a room number for that course. And then lastly, you have a web address for the course. Now all of these could probably be shared amongst multiple courses, right? You could have students who are taking more than one course. You can have the same textbook used in more than one course, especially if you have different sections of the same course. Now let's forget that. Let's pretend that the textbooks are specific to a particular course. We only have one section of each course. So this is a composition relationship. We do not share our textbooks between courses. However, this is aggregation. Same student may be a member of multiple courses. Yeah, did I spell that right? No. Aggregation. The room. Several courses can share the same. So is that aggregation or is that composition? The web address. Each one has their own DTL section. So that's composition. You diagram them different ways. If you're doing a UML diagram, the filled-in triangles, the filled-in diamonds, representing the composition because they're a hard one-to-one relationship. Aggregation is a softer form of relationship, so you use the hollow diamonds. And if it's a one-to-many relationship, then you use an asterisk near the side of the object that is owned. And if it's a one-to-one relationship, then you put a 1 there. I'm kind of spacing out on when you would put a higher number there than just the 1. Anyways, one-to-many or one-to-one. That kind of makes sense. I don't think we need to code any examples of that. Do we need to code any examples of that? Nah. Alrighty. I think we know enough that you could probably do the Chapter 13 quiz, especially since you have your book open. Just keep the book open. Any words you don't understand, look it up in the book. But we have talked about inheritance several days. We have talked about subclasses and superclasses, and that subclasses are derived from superclasses with the extends keyword. We've talked about the difference between private and public. And I believe I've also talked about the fact that if you do not specify private or public, it goes to something that looks like public, but it's actually public only on a package level, so other things in the same package can access it. We know how to make a default call to the superconstructor. If a class does not have a default constructor, you absolutely have to put a call to the superconstructor. If it does have a default constructor, I believe you can leave it off, but it's never a bad thing to go ahead and specifically call the superconstructor inside your constructor. If you're going to have a constructor, you may as well call the constructor of the object that you inherit from, your superclass. And what does the final keyword mean? If you declare something as final, if you make it a final class, it means that the data, that the class is not going to change. The object is not going to change once created. And if you see a need for that, great. You're going to create a point, 1, 3, and you've decided that nothing's ever going to change the x and the y coordinates of that point, then you can make it final. So if you want to specify that a method definition cannot be overridden with a new definition in a subclass, you can also use a final modifier in a different sense. And now I'm slightly worried that I gave you the wrong definition of a final class. What we're saying here is that getName is the final method. It cannot be overridden by an inherited class. So down here, if we made a class called employee that extends person, but getName is final, then we can't change it. Is that your final answer? Yeah. So this would be a compilation error.
Final was just Java's version of a constant.
It is, and it's used in slightly different contexts than the word final is in const is in C++. And it's kind of strange that that's the case, since this is based a lot on the C++ concepts, but also different. What assignment are we on? What lecture are we on?
N.
We're on N? Alrighty. So if we have a class, and it's got a member, private member, and as a constructor that sets that member this dot x equals x, it's telling us that we could make this a constant, right? Once set, this thing's never going to change because we're not going to add a setter and mutator for it. If we do, we'd better no longer make it final. All right, am I right in that you can add the keyword here? Does that make it all read-only? No, it just makes it where we cannot inherit from it. So class who extends boo, and it says, nah, can't do that. Boo was final. Oh, no, it's actually complaining about the constructor. All right, public who takes an integer, and it calls the superconstructor. Still complaining. Cannot okay, now it gives me the right error, which cannot inherit from this. So the final keyword is being used in two different contexts. It's being used to indicate that a variable cannot be changed by the class once it's assigned in the constructor. And it's also being used to indicate things that cannot be inherited from, that cannot be overridden. A use of C++ uses an awful lot that I do not recall seeing in Java is to tack the const keyword there, or the const keyword at the beginning. And what that does in C++ and not in Java is it says that even if you have a read-only object, you're allowed to call that. Right? You're allowed to get its value. It's a read-only object. It was declared as a constant, so you're allowed to call that. But if it was a setter, you can't make it final because it's supposed to actually change the value of it. But that's C++. That's not Java. It's weird how the same languages use these same ideas slightly differently. Alrighty, I'd like to talk about, are we good on composition versus aggregation? Okay. I want to talk about threads, meaning I'm probably going to delete everything that I've got here. The idea of threads. You've probably opened up Task Manager, right? Or whatever your Macintosh version of it is called. Start Task Manager. You can come over here in Processes, and you can see each process that's running on your machine. And you'll notice that Chrome is insane and opens 1 million processes. That was the selling point of Chrome back when it was first invented. Google bragged about that every window was its own process. Why? So if one of your windows crashed, it wouldn't kill the application. It'd just kill that window. So that's a good thing. But a side effect is that the more windows you have open and the more extensions you have loaded and things like that, then Chrome can crank up like, 20 or 30, 40, 50 different processes running. And that's not a big deal. Shouldn't be a big deal on our modern fast machines. But if you ran Chrome now on a Windows 7 machine and you had a whole bunch of extensions loaded and you tried to get a whole bunch of... So anyways, separate processes are like separate programs. Each program is its own process. Now a program can also marshal other processes, right? A program can actually be communicating between the two like we're seeing in Chrome. But Explorer is a process. And if I kill Explorer, well, all of a sudden I can no longer interact with my operating system. My taskbar is gone. Good thing I can come up here and go to File, New Task, and launch Explorer again. Otherwise I'd be up a creek. But each application wants to be able to do multiple things at the same time. Right? All these numbers are updating. More of them are probably updating at the same time. We want the application to be able to do stuff while it is closing, while it is opening. If I'm in Notepad and I do File New, I don't want the rest of the application to remain frozen while I'm trying to create a new. You've probably seen the case, especially in older programs or older operating systems, where it just kind of hangs. The whole thing hangs, and then when you start dragging the window around, it leaves a path of windows. And it's because it's not multi-threaded. It's single-threaded, and it has reached a point where that thread is stuck, and so it cannot respond to system events. System events like redrawing, or being minimized, or maximized, or having your window moved, or stuff like that. So you want multiple threads so that if something happens, like if I click View, it doesn't hang the whole thing, right? Something else could be dragged on top of it, and then when it was removed from it, it could redraw itself even though I have the View menu clicked. And it does that through threading. A threading is kind of a lightweight process. It's a composition thing because each thread is owned by only one process. So we can create an application that uses threading. Maybe just to update elements of an array. Maybe just to print out the word hello to prove that we have several different applications going on at the same time. For the scripting class, we wrote a port scanner, which took a long time to run through a series of ports. If you wanted to scan 20,000 ports, 10,000 ports, it would have taken 10,000 seconds at the rate we were going. But you could rewrite it with threading and launch 1,000 threads at the same time, and it would have taken only 20 seconds instead of 20,000 seconds because you have multiple things going on at the same time. Nowadays, processors are really good at managing threads. Your multi-core, process, your multi-core processor means that several things can be going on your chip at the same time. And they're going so fast that they're able to task switch between your processes and your tasks so fast that it looks like they're all running at the same time. So let's play with threading. Guess what? Threading are classes, just like all of our other classes. And I did bring my cheat sheet. Okay, so we want a thread. And it's not going to do much. Maybe it's just going to put numbers on the screen. There's a thread class which we will extend. So what are we going to call our thread? CoolThread, because it's so cool. So class CoolThread extends thread. Is that enough? Does it complain that we don't have enough? Are there any mandatory methods? Is it an abstract class? It does not seem to be an abstract class. On the other hand, it's not going to do anything. We need to put a constructor. And what a constructor is going to do is just take a number of how many times it's supposed to loop. Now I think we're going to modify the constructor in a minute to accept a reference to the class that is invoking it. But for now, public CoolThread has to have the same name. I forgot, I always like to capitalize the first letter of the class. CoolThread, and it takes a number of times it's going to loop. System.out.println, parentheses, and let's put that inside a for loop. For int I is equal to 0, I less than I plus plus. System.out.println, I. It might be cool if we gave each thread a different identifier so we could see which one was working at the same time. So why don't we make a member called name and then set that name inside the constructor. So I'm going to come up to the top above the constructor and add string name. And I guess I could give it a default value, but the only constructor we have is going to assign it immediately. Why don't we make that one of the arguments that we pass in to the constructor? So CoolThread is going to pass in string name and also accept integer num. The first line of the constructor, or the last line, should be to set that name. This.name equals name. That may be enough. There's certainly more than we can do with it that we may be modifying it to do. Like, let's make it pause between printouts so that we can see those numbers come up. There is a pause command available to us in the operating system's library, but there's a specialized one that's thread safe, meaning that multiple threads can use the same pause counter. It will not possibly crash. So maybe let's use that. Every time we print something out, we're going to pause. So, time unit dot seconds in all caps dot sleep. We're going to sleep 2 seconds. It's funny, I saw days coming up and stuff like that. You know, we can make it sleep for several days. And what do you know? It wants us to handle an exception. What is that exception? What if the application is supposed to be dying right now and all the threads need to be shut down, but the thread is sleeping? Can't be shut down. So, and if it is shut down, it would cause an exception. Note that this is a checked exception, meaning we have to implement it. We have to add the catch for it. So we're just going to stick a little try here. Or you know what? We could put the whole try outside the whole thing. Right? We're allowed to close the entire chunk of code, the entire loop in a single try. I'm kind of feeling like, no. I'm going to go ahead and do it here. No, I'm not. I'm going to do just what I said. I'm going to come here, try all this stuff, and now I'm going to have to tab some stuff over so I can add the catch. Right? Because my catch is going to be here. Let's tab that over. There. Now I'm about to get lost on what is what, so I'm going to start adding comments. This is the end of my class. This is the end of my constructor. This is the end of the try block. And that's the end of the loop. And I'm just going to let NetBeans add the catch for it since it's so helpful. Add a catch clause, which it did. And not only are we going to let the logger handle it, we're going to add a return statement so that it just kills the thread. We return out of the thread. Alright, I've stuck a lot of stuff that should not have been in the constructor. This should be in its own function, meaning I'm going to have to go back up to the top and close the constructor and create another function underneath it. This would probably work, but it's weird to have a thread that kicks off and starts running as soon as you create it. That's not really multiple threading, right? You create an object and it just sits there, you know, interrupting the flow of the program. So you see where I come up here? We passed in a name. We're passing in a number. We need to be setting two members. We need to set a this.num and a this.name. And then we need to close our CoolThread constructor. So I'm going to close that right there. I'm going to set this dot num equals to num, which means I have to have a method for it. Int num. And then I better create the header for this function. I'm just going to call it do work. Public void, doesn't need to return anything, do work. Parentheses in parentheses. Alright, now's a real good time to stop and make sure it can compile for everybody, including myself. It's not going to do a darn thing when I run it, but at least it proves that it compiles. Okay. Now my little comment at the very end of the do work method is wrong because it says end of constructor. It needs to say end do work method. All right, give everybody a chance to catch up. So we want to invoke our thread. As the language is doing, you could create a thread object and call it, but it's not going to be multi-threaded. So if we did this, CoolThread C1 is equal to new CoolThread parentheses. It's got a name, Fred, in parentheses, and it's got a number of times it's supposed to repeat, like that. And then it's supposed to do its work. C1 dot do work, like that. Then copy that stuff and paste it and just make it C2 and C2 dot do work. Give it another name like Barney. So C2 is equal to new thread, Barney, and then C2 dot do work. At this point, we're just kind of testing to make sure that our code isn't broken, and what I mean by that is that the thread class can actually construct itself and the do work method actually does something. Alright, every 2 seconds it's spitting out a number. Now I had intended for it to print out the name as well as the number. So I'm going to go and modify the do work method to do that. And then I'll come back down and leave that. But up here inside do work, I'd like for it to print out the name of it as well. So name plus quote space quote plus I. Just so I see Fred 1 and Fred 2 and Fred 3 and stuff like that. So this is a line that I just changed. Now I'm going to scroll back down. I'm going to see if this stuff actually works.
Mine's doing all the Freds, and I don't have any for the other guy.
Right, but he's got to get all the way to 10 before he relinquishes himself and the other guy starts working, because it's not multi-threaded yet. Now Barney kicks into gear. But we want them working at the same time. It'll take forever for both of them to do their job, especially if we created 20 threads or whatever. So these are thread objects, but they're not actual threads. Well, they are actual threads. They're actual thread objects because we extended thread, but we're not triggering their work in the right way. We're telling them to work sequentially. They're not being launched. They're not being thrown overboard to swim on their own. So to do that, we're going to call C1.start. and C2.start. So delete do work and replace it with the word start. And what that means is, yo, start running and don't wait for me to finish.
What are we starting? We're not calling the method anymore.
Right, it's supposed to trigger the do work method automatically. I seem to have something odd going on where it's not invoking the do work method. Oh, my mistake. We have not added a run method. And I wish that this had been declared as an abstract class, so you had to override the run method, and you got an error if you did not. And all our run method is going to do is to call do work. So shuttle back up to your thread class, and either above or below the constructor, we're going to add a do work method. Public void. No, we're not a do work. A run method. Public void run. Parentheses in, parentheses, and all run needs to do, I mean, it could print a little happy message. System.out.println name plus is now running. But then it has to call do work to actually get the work done. So do underscore work. Nope, do capital W work. He's offering a little comment here. Add the override notation. That's not a bad idea. All right. So we were starting him, but we didn't have a run method, so he wasn't doing anything. Conceivably, we could put all of our code that we had in do work inside the run method instead. So honestly, I don't know why I planned on breaking them up. I guess so that we could have the thread be able to perform multiple types of jobs. And when you called run, it'd be able to pick which one it wanted to do without having a great big if block inside it. All right, now it's going. So it's only going to take 20 seconds to accomplish this rather than 40 seconds. For funsies, we could put the thread creation inside a loop and create 100 threads going at the same time. Anybody not have the run method ready to go?
It doesn't, like something about mine says it doesn't have a body.
I got to see
Yeah.
So, is there a
instances.
I was just asking, like, when you have two starts going on, but like when you have the two starts going, is there a gap in time between the two, or just it automatically starts and then it goes to the next line and it starts the other thread?
Yeah, what start is kind of like fire and forget, immediately return and keep going. So whatever gap is like in the number of nanoseconds or whatever, it's not waiting for the other one to complete before it kicks in gear.
Because I was wondering, because you were talking earlier about how you read a loop to create 100 of them, and I was just wondering, like, if you have 100 of them, is there like a gap in time between like the first one and the 100th one, or is it just like as it used to be milliseconds?
It should be really, really small gap. Let's go ahead and put our creations inside a loop so that we can create a whole bunch of them at once. Aha, I left the recorder going on. Okay. So here, just as the first line of main, for parentheses int x equals 0, x less than 100, x plus plus, curly brace. And then after the C2.start, do a close curly brace. And if you feel like being all tidy, you could take these middle 4 lines and tab them over. Now that's going to create 200 threads. Half of them are going to be named Fred, half of them are going to be named Barney. We might want to distinguish them a little bit more than that. We could do a plus I, so it'd be Fred 0, Fred 1, Fred 2 there, and we could do a plus I there. Since Java is nice enough to convert things to string on the fly. Or is it not? Oh, that's because it's called X. What do you know? All right, so here's what I did. Is I want them to all have unique names, so it's going to be Fred 0 and Barney 0, and Fred 1 and Barney 1, and Fred 2 and Barney 2, and so on. And there we go. You see how fast it created all of our threads, and now they're all doing their work simultaneously. Let's create 1,000 of them.
No. Are you trying to crash it?
Eventually, we might run out of stack space. That's kind of fun.
Yeah, that's about right.
All right, I think we've kind of proven the point. I'm going to stop that.
But I mean, at that point, it's kind of fun that you continuously add so many that it's a non-stop showing of every single one of them, as opposed to earlier when you only had 2 and it actually takes 2 seconds to start.
Yeah, and it's still, I mean, we could time it. It still only took about 20 seconds for it to work. 27 in this case, right? Having that many bogged them down a little bit, but imagine if we created 10,000 things that took 20 seconds to accomplish each. That would be 200,000 seconds we would have to wait for the task to complete, and instead we got it done in 27 seconds.
Is there a way to, well, never mind, I take that back.
Now there are times when you want to wait for a thread to complete, which sounds silly, right? That's the whole point. But you could launch 100 threads, and then you could say, nah, I want to wait for them all to complete. And we could do that. Not gonna, but we could. But we have another problem now. What if they all share one piece of data, and they're all trying to update that one piece of data? But we have, you know, with our multi-core processors nowadays, the ability to have 2 threads running at the exact same time, which used to not be possible, right? It'd task swap between them. You know, you can give thread 1 a little bit of time and thread 2 a little bit of time, but with a 4-core processor, 4 of them could be running at the exact same time. They're all trying to write to that single byte of data, and that data could get corrupted, right? Starting to write, you know, the first half, and then the second one comes and it's writing the second half of the byte at the same time. A single byte might be able to get away with it, but what if it was a string or something? What you can do is you can declare a variable as synchronized to say that all access to it is synchronized, meaning that the Java forbids multiple threads from trying to change it. And if one of them is changing it, then the other one just has to wait. So what I want to demonstrate next is that even though these threads are in their own class, they can interact with the main class. Now in C++, you just mark that they're friends. We can't do it quite like that. C++ is a weird, complicated, ungainly beast. So what we're going to do is we're going to make a piece of data here called counter. We're even going to mark it as private. Going to initialize it at 0. Something is really bugging me now. In my examples here, main is not static. I don't know why. Private had better be marked static. It's just not in my example here. And I should not have stuck this inside main. Sorry. Delete, delete, delete. This is a completely different element of the lecture. So go up to here, right under where the class lecture is declared. Private static int counter is equal to 0. We're not going to add a getter and a setter for it, although I guess we could. And then we're going to write a method that adds to the counter and returns it. So public int increment counter, parentheses, in parentheses. Oh, I see why I did it the way I did. Okay, I'll show you, and then we're gonna abort on this one because it's not gonna work. The keyword that marks something as being synchronized, and don't even bother typing unless you're just going to comment it all out like I am, is synchronized. And then you give it a reference upon which to synchronize. And then I could do this dot counter plus plus, and I could do return this dot counter. We've already got a problem because we're inside a static class, and so we should not be able to return static this and static that and static the other. We have no this reference to lock on. If this is not declared static, which it would have to be, I forgot to put static in front of it, what it does is it enters the method and it says, yo, I can only do this one at a time. And so all the other threads that are trying to do it at the same time have to just step in line until this code gets done, and then the next thread can come into it. So this is like a little gateway that lets only one thread in at a time to perform that function. Now what I did is I made a separate class that had a main, and I called that main from this main in order to have this object with which to play. So I think I'm not gonna mess with that. But what if we do have something we want to be able to pass to it? What if we have some kind of method that we want our threads to be able to increment? Like we want them to all be updating some kind of array. I'm going to go back to having a counter there, sorry. Static int, I wish I hadn't deleted all that. Delete, delete, Control Z, Control Z, Control Z, Control Z, Control Z, Control Z. Alrighty. There, now I'm happy where I am, almost, except this needs to say public static int increment counter. And inside here we are going to increment the counter. Counter plus plus, return counter. And I want the threads to be able to increment the counter for whatever purpose. They're going to call it 20,000 times. Right? Because we have 1,000 threads and they're looping. But in order to get that to happen, again, we don't have a this reference. I completely botched this portion of it by not having a this reference for us to bounce around. And I really don't want to take the time to fix that. I'm just going to leave that code, or you can delete it. But what if we had some data that we needed to pass into CoolThread? We already are passing something, right? We're passing the number of times it's supposed to repeat. Let's also pass in an array. Array events. Int array, but since we're declaring an int, we better put our square braces there. Int square brace array equals new int 10. And we're going to pass that array in as part of our data to our constructor. So we're going to have to modify the calls to creating the thread, and we're going to have to modify the constructor to accept it. Or maybe we just make a set array method that we can invoke. I'm almost liking that idea. We should go and modify the class first so that we have it clearly thought out before we come back and do this, though. So I'm going to scroll back up to the CoolThread class, and we're adding one more method, which is an array reference. Int subscript array. And we need a setter for it. Void, or public void, set array, parentheses, int, open close subscript, array, close parentheses, open curly brace, this dot array equals array. And now we have an array we can play with. So down here inside our loop, let's just add 1 to whatever thread, to whatever counter we're on. So when I is equal to 0, we're going to increment element I, element 0 of the array. Array subscript I plus equals whatever number we're on, num. Right, if we're the first thread, we're going to be adding 1 to it each time. If we're the 10,000th thread, we're going to be adding 10,000 to it at each time. So all we're going to have to do is to go down, and after we create the thread, we're going to have to call set array and pass the array reference in. And we're going to have a whole bunch of things working on the array at the same time. And it would be a real good idea to try to synchronize access to that, so that only one thing is actually updating that array at the same time rather than 10,000 things. 10,000 things trying to hit the array at the same time, modify the same piece, same bytes, is a recipe for malfunction. But who knows, we may get a malfunction, we may not, since we're probably not going to print the results of the array. Okay, so before c1.start, let's do c1.setArray, parentheses array that we created. Do the same thing for C2. C2.start, C2.setArray, parentheses array. And let's not create so many threads. Nah, it's okay. But here's a point where it would be a good idea for us to hang out waiting for everything to be done. Right? If we were going to print out the array at the end, we would want to wait until every array was done. Every thread was done. And I forget how to wait for the arrays, for the threads to finish. For one thing, you'd have to keep track of all the threads. You better add them to an array list or something, other than just create it and then make them anonymous variables because, C1 and C2 disappear. We no longer have their names. But we could just wait 30 seconds and then print out our array. So, but then we're going to have to do this business about time unit dot seconds dot sleep. Is there an easier way to do it that doesn't require exception handling? Java sleep. Pausing execution with sleep. I'm just going to make it sleep for 30 seconds. Thread.sleep. All right, let's give that a shot. After we start all of our threads, we're going to do thread.sleep. I want to wait 30 seconds. And then, oh, let me guess, you want to try and a catch as well. For Pete's sake. Okay. Click on it, surround with try catch. And it did it all right. Great. Fastest way to fix that problem. And then let's print out the array. For int x colon array. Let's address it as an index. Int I equals 0, I is less than 10 because we have 10 elements in the array. Or, let's be really nice, array dot length, and then I++, system dot out dot print line I plus a space plus array subscript I. And I'm just moving my braces around and stuff like that. And it's possible I've broken all y'all's code. Let's make sure it works on mine first. Alrighty. So main is waiting 30 seconds, waiting for everybody to do their job. Main went to sleep for 30 seconds. And the way you interpret sleep 30, well, unfortunately, that was probably milliseconds. I should have looked up the meaning of the parameter, and so it probably printed out our answer right at the very beginning. Yep, that's why we're not seeing any answer down here at the beginning. At the end, I'm going to do show javadoc on the sleep command. It's probably going to tell me it's milliseconds, so I better wait 30,000 milliseconds. And what that really means is wait at least 30,000. The operating system controls how long it sleeps. That's a minimum. Alright, hopefully that sleep is really working. It's hanging out, waiting 30 seconds for the threads to do their job. This is a cheesy way to do it. We should actually be waiting for all the threads. And if I remembered how to do that, we'd be doing it. And it may have taken more than 30 seconds. No, we're still waiting. And there, no. How do I know if it's run more than 30 seconds or not? Okay, there we go. It finally worked. And whatever was in the array got incremented with all these values. I don't understand how those values worked. Maybe they got corrupted being written to. I was expecting 0 to wind up being 0, right? Because we were always adding I, that counter to it, to the 0th place, and then 1 I was expecting to see, Anyways, so we've seen writing to data that we passed in. We also probably have seen the fact that you can get corrupted data if you have multiple threads trying to write to something and it's not synchronized. Can we perhaps possibly do synchronize and then just set it to be synchronized on that object itself? Let's give it a shot. I'm not sure if this is going to work, but up here, where we were adding to our array, right there inside our for loop, that's where I'm going to try to synchronize it. Instead of using this reference, I'm going to use the array itself as our reference. So synchronized subscript array in subscript, open curly brace, add 1 to that specific. Oh, I see why it was adding that. Anyways. And so what this means is, pause until that is done. access to this variable has to be synchronized. Only one thing can change it at the same time. Just waiting 30 seconds is kind of for the birds. But I'm curious as to whether we'll see the same results or not. We should see every element in the array being the exact same number. Because they loop 10 times or 20 times or something like that, and we have 1,000 of them being created. There, now they're clean, right? We saw that. We saw data corruption. This is the first time I've ever demonstrated data corruption in a thread-based application, so I'm real stoked. All right. That's enough about threads, I think, unless we have questions. I'm going to pause this and wander around, see who I managed to mess up. If you run it and you don't see your arrays, it's because it was only sleeping for 30 milliseconds. You didn't catch me making that change to sleep for 30,000 milliseconds. That's what's cool about that other syntax. We should have just used that other syntax. I was hoping that we didn't have to put, try catch around it if we didn't. But we could just as easily have used this syntax, wherever it was. Control F, sleep. Time, unit, second, sleep. And I could replace that call down here to use that. And then set, 30. A lot clearer what it's doing. All right, anyways, that certainly was not necessary. How are we doing on all of our brace placement and stuff? It's working? Cool.
I just got 100 instead of 10,000.
Well, I'm surprised that they're not all the same. It's like we're still seeing the data corruption that I was thinking was being avoided, and I don't know why. I mean, they're all close. They're all like within 10 of each other. It's interesting. I hope that would prevent that from happening. But I can't say that we're going to be able to take the time to debug why it's not. Who else? Anybody, when y'all run it and the array dumps, if it did, does it print out all the same numbers or different numbers?
Sorry, I
It's
didn't
not
forgot
out.
to change it, that's my bad.
Still waiting, but I ran it beforehand. I'll two now.
Okay. Thought yours made up when it ran.
No.
Did it?
Yep.
Numbers at the bottom. So yours were all the same?
Yep.
Maybe I got a brace to offer.
You're special. No, I mean, they're so close that it looks to me like the code is working. You created a different number of threads than I did,
Right.
right? But I wouldn't have expected that to matter.
Under whatever you had originally, I left for
Right.
here, I guess.
Yeah. Change that to 3, just out of curiosity.
Just 3?
Yeah. Oh, great, we're still gonna have to wait 30 seconds. All right. That run, what are we doing back here? Yeah.
Well, these are still different. But one of them's different, all the rest are the same.
After these stuff is done, or after I guess guys, we have magic numbers out the wazoo on this. Right?
A 110 here and all the rest for 120. Okay.
The Synchronize is supposed to fix that. I don't know why it's not. Your machine is magic. It's got chaos theory involved.
Yeah.
Wait, so what's
So what values might we want to replace with constants? Maybe the number of threads we created. Maybe the amount of sleep that each thread waits, right, rather than 2 seconds. Maybe the number of times they're supposed to loop. And then this calculation down here where we were sleeping 30 seconds or whatever would need to be tweaked, something multiplied by something. But the best way is to wait until the thread is done. One more thing I want to throw in is to try to break one of our threads with an interrupt function call. I'm wondering if we're going to be able to do that, and maybe we ought to just go on to another topic. Almost out of time. Okay. Guess what, Lynn? Brian's worked perfectly. You're special. I really don't know why it's not doing that.
Oh, wow.
I don't know. I don't know. Why? Oh. That one is there. It's non-synchronized, right? Because it's out of the synchronized block. And so we did have some stuff. Right, you were updating it twice. Now it would be
right.
perfect. Yeah.
Oh, that was perfect.
You are. You're special because you demonstrated the corruption. The mistake we saw there is that when we added the synchronized block, this was still left outside of it. So we were writing to it in a non-synchronized fashion and getting the corruption. So what if we wanted to try to cancel one of our threads? Getting tired of waiting 30 seconds every run though. You ought to be able to cancel a thread just by calling C1 or C2.interrupt. That tells the thread to stop. Your application is being shut down, you may want to call interrupt. But we've got a problem. It says sleep interrupted. It created an interrupted exception. I honestly thought we had handled that. Was I printing an error message if it got interrupted? Okay. You know what's happening? No, I can't say that. I don't know what's happening. I don't know why this is not returning right here when it's interrupted. System.out.println, parentheses quote, thread was interrupted. And this doesn't work right off the bat. Yeah, see, some of them are being interrupted. It's supposed to return at that point to prevent that thread from doing any more work. However, what we're seeing is that the thread is continuing to run anyways. Or maybe the thread is being interrupted before it gets to that catch. But we have try catch put in around the entire loop, so I'm not sure why I'm seeing that. But that's the idea. You may need to kill your thread early. You should be able to kill the thread early by calling .interrupt on it. When you call .interrupt, the sleep should be interrupted, and then it should catch that and handle it in such a way. In this case, we just tried to kill the thread by returning straight out of it.
I clicked on that thing and it takes you over into the thread logic. That link?
Yeah, did it take you inside the thread class?
Yeah. Not mine, but
Yeah. But here's something to notice. It didn't stop the application. we got exceptions, but it was only the thread that got it killed, right? And so half of our threads, all the thread threads, are getting to run on their merry way. Even though the other ones, all the Barney threads, either quit gracefully or they generate an exception. That's another cool thing about multi-threaded processes. If you get an exception on one, it doesn't have to kill the whole program. You see here? Thread was interrupted, thread was interrupted, thread was interrupted, and then eventually we get to the point where, right, go, right there. Sleep interrupted. Is that just a result of a logger? If I comment out the logger, is the red text going to go away? Yeah. Okay. I was confusing the results of the logger with the exception. They are canceling themselves cleanly. So all the Barney threads were terminated with extreme prejudice right after we started them, but the thread threads are allowed to run on their merry way. Neat. Alrighty, I don't know where to take this example unless we were going to rewrite it in such a way that we could pass a this reference to it. The way that looks, and I'm not going to actually do it, is you create a thread class that has a constructor and the first element in it is of the type of your main class. So for example, in this case, lecture N, which we could call L-this. And then inside your do work thread, right, inside of do work, or inside of run, public void run, you could actually invoke methods in your main class. Instead of calling it this, I would call it lmain or something like that to indicate that this was our primary client class that was invoking the thread. And so down here we could use lmain to access elements of our primary class, the class that had created the thread. Yeah, whatever, you know, print hello, whatever methods inside our main class that we were trying to call. And so then down here, when we were creating it inside of main, inside some other class, then when we created our new class, myThread empty equals new myThread, we would pass in this reference. And our thread class would then be able to use the this reference to access all the elements of our main class. So if we had a print function, for example, that took a string. Hope that kind of makes sense. We're not going to have time to demonstrate that. Maybe we'll get a chance to demonstrate that when we're doing user interfaces or when we're talking about disk access and going to the web. But you can bounce this reference around to threads and let the threads call methods inside your own class. It's called a callback function. The idea exists way back all the way to before object-oriented programming in Windows 3, where if you wanted Windows to call your function when the application was closing, you gave Windows a callback address so that when the close box was clicked, the operating system would know that that window was supposed to close, and it would send a message to your app saying you better close that window, and it would call your function in order to handle that. About time to stop. I can't think of a way to extend talking about threads any longer. Of interest, guys, this is more like real-world programming than what we've done in the past. Hope it was of interest.
Yeah.
Now all y'all's projects have to be multi-threaded. I don't care what they're doing. No, I'm kidding. Got to play 17 Hangman games at the same time.
That'd be awesome.
Go for it.
It'd be so confusing though.
No, you just say game 1, guess a letter.
Game two, guess a letter.
Keep
Yeah.
going through every single hangman until, and you
But to keep track of them, it'd be like you have to
That's
know.
the fun of it. You periodically